All right. All right. Well, welcome back to the CypherCon podcast, Michelle. It's great to have you back
Oh, it's great to be here. Thanks for having me.
on our special COVID-19 episode. So we talked last year. We had a nice conversation about TDCS and CRISPR, if I remember correctly. And I remember that being a really fascinating conversation. And a lot has changed since then. CypherCon, today is April 5th. CypherCon was supposed to happen April 2nd and 3rd. So 2 days ago, we would be wrapping up CypherCon, but that's not the case. And you were supposed to give a talk at CypherCon this year, right?
Yeah, I was really excited. CypherCon is always like a really fun time. Love speaking there. The audience is always very, very nice, but I can't argue with the decision to cancel it.
Right.
I'd be a real huge hypocrite.
Yeah, definitely. And what were you going to talk about? What was the quick thumbnail of what your talk was going to be on?
So I was originally, when I pitched this talk, it was in January, and the public was just barely starting to get wind of this, novel coronavirus is what they called it in the early stages. I was like, it would be real interesting to give a talk about, pandemics and how information spreads and, all of these like conspiracy theories that are cropping up. But, after like a month or so, I was like, there is too much information about coronavirus, this novel coronavirus floating around, and I think that I should honestly just be giving an honest to God like facts talk about coronavirus from someone who's in the public health sphere. And then it got canceled. So
so now we're doing the talk.
Yep.
More of a conversation rather, but let's dig right into it. Let's start at the beginning. Like, what is COVID-19? Well, what is this virus?
So COVID-19 is the name for the disease caused by the virus SARS-CoV-2. So that stands for Severe Acute Respiratory Syndrome Coronavirus 2. We named it that because it's similar to SARS-1 in certain ways. Like, it's also a coronavirus. It also causes severe acute respiratory syndrome, and we're trying to stay away from names of people or places as a disease and virus names. So,
and SARS-1 was what we saw, the SARS, the SARS disease. It must have been like 8-10 years ago or something like that. I can't remember.
It was actually longer than that. It was like, I feel like early 2000s.
Okay.
So like almost 20 years ago.
Really? It was that long? Wow. Huh.
Yeah.
But so this is like a different version of that. You're saying that this is the virus that causes this disease.
Yeah, so SARS-CoV-2 is a different virus than SARS coronavirus, like the original. I'll just refer to it as SARS-1, even though that's not its official name, just to delineate the two.
Sure.
So SARS-2 is of the same family of viruses. So they're both coronaviruses. They're both beta coronaviruses, so that's a subset of the family Coronaviridae. They're both RNA viruses. They have a similar, genomic structure, not identical, and there are some interesting differences on a molecular level, but that's sort of like a bit too technical. But so it's a RNA virus, which means that it is a single strand of genetic material as opposed to double strand, and also that it is much more mutatable than DNA viruses and much newer. There are some interesting, biological reasons because that this is true, but it's not really important for what we're talking about. Coronaviruses are named because they have a crown. So corona means crown, and that these are these little like spikes embedded in the membrane of the virus, if you will. So it's like a ball with a bunch of little like spike proteins and other proteins on the surface.
Okay. All right. And then, well, one of the things that I forgot to mention and touch on, so since we last talked, you moved out to Berkeley and you're going to grad school, correct?
Yeah, I'm an infectious disease master's student in the School of Public Health. So,
So you're right in the thick of it.
Yeah, it was so surprising that people were like asking me my opinions, like unsolicited, about things going on in the world. And I went on a ski trip a few months ago, before I started social distancing and all that, and people would be like, "Oh, where are you from?" And I'd tell them that I'm at Berkeley because I'm doing grad school. They'd be like, "Oh, what do you study?" And I'd be like, "Infectious diseases." And they'd be like, "What about that coronavirus? What do you think about that?" And that was crazy. Not used to it.
Yeah, sure. You're the expert here. So what's changed since then? I guess, like, as far as like your school studies and stuff, you talked a little bit about how you're kind of mobilizing to do some work for figuring out what to do with the pandemic, right? So
Yeah, so I know that labs in Berkeley and around the globe are mobilizing to fight coronavirus, COVID-19 rather, sorry, on a large scale. And there's just like incredible scientific collaboration and conversation going on. It's actually incredible to watch. I know that labs on Berkeley campus are lending equipment like RT-PCR machines, QT-PCR machines, trying to supplement the testing capacity. They're donating time on their lab equipment, so they're like fume hoods and stuff. I know that there's interesting work on diagnostic tests, like serology tests, versus the existing RNA detection PCR test. There's also really cool work going on looking at the mechanism of the disease and trying to identify therapeutic targets. I know that like in most of my classes, we spend like half the time just talking about COVID-19 and SARS-CoV-2. So I would just like talk about COVID-19 like 5 hours a day at this point.
yeah. Well, what do you mean by therapeutic targets? What does that mean?
So for example, you could, there are a lot of ways that you could look at this. You could look at this like, what about this virus creates an antibody response? So if we look at like a mouse model, we could look at what parts of the virus create an immune response and how to, make that more efficient in ways. And that would give us clues on, vaccine development. There are already vaccines in the works, by the way. There are already vaccines in clinical trials. Oh,
wow. I didn't realize that they had them in clinical trials already.
Yep.
That's fast, right? Like usually it takes a lot longer.
It's unprecedentedly fast. Like normally it takes multiple years, sometimes like 10 years to push out a vaccine. The timeline that they've given us with 12 to 18 months, incredible.
Wow. So anyways, we were talking about, what would you call it? Therapeutic target. Yeah, therapeutic target. So that's basically the looking for a cure kind of a thing. Is that what I'm hearing, right?
So let's step back a little bit. Tell me what you mean by cure.
Yeah, that's a good question. cure. I guess a vaccine, you know, something that would make it so that it's preventable, like you wouldn't get it or something like that. Like I guess that's what I'm thinking about. Yeah.
Yeah. So like, see, I asked this question because most people, when they say the word like cure, they either mean treatment of the disease, or they mean like prevention or prophylaxis, or some sort of combo of, you know, those two things. It's sort of a little bit nuanced, because of course no treatment and no, you know, prophylactic measure is without side effects. And the thing that we are looking at is, first of all, what works or what could work. So we would look at how, you know, it works in vitro, so in test tube, and then we would scale up to, you know, mouse models, and we'd scale up to, you know, human trials. And that's normally how it works with vaccines. For treatments, sometimes we can look at things that we already have. So you might have heard about remdesivir, which is a drug that Gilead has, you know, had in the works for a while, and is in trials to be used for treatment of COVID-19.
That's a current drug that's out there right now?
I'm not sure if I'm not sure exactly what it's used for, but it is a drug produced by Gilead, and they are looking into using it in COVID-19 patients. I know that also the combination ritonavir-leponavir, which is a medication used for HIV/AIDS, it was in trials, but that didn't show very promising results from what I saw. So that was unfortunate. And it's all sort of like incredible to see how all of these different like parts of the healthcare system and the research pipeline are all like working sort of together to try to like mitigate this crisis.
Sure, yeah, it sounds like a really great collaboration. Since we're talking a little bit about some of the treatments, what do you think about like the chloroquine? Am I saying that right?
Hydroxychloroquine.
Yeah, hydroxychloroquine, the malaria treatment. I've heard that there might be some promising things there, and I don't know. I only know what I hear, right?
Yeah. And part of it is because it's such a polarizing thing right now, especially with, you know, recent political events. Right now, like, I'm kind of sorry to say this, but it's just too early to tell if it really works or not. And the study in France, the preliminary study that was referenced for that, showed benefit, but it had like serious methodological flaws. Like, first of all, it was not randomized. And when you look at their data, the people who got the treatment already had lower viral loads than people who didn't get the treatment. So maybe they were further along in the disease. Maybe they were already like clearing it by themselves already. And second of all, it's got a very small, you know, treatment group. It's 26 treatment patients. And only 20 of those 26 treatment patients were included in the end analysis. One was excluded because they stopped treatment due to nausea. 3 were excluded because they were transferred to the intensive care unit, the ICU. So, and one of them just fucking died, so they didn't include them. So they didn't include some of the worst outcomes in their end analysis. There's, you know, other small studies that say, yeah, there's some benefits, but there's also other studies that say that there's no difference. So we just don't have conclusive evidence. And, you know, there are, I know, a lot of ongoing trials on this. I was reading an article that was published a few days ago that said that there was 10, and I'm sure there might even be more. So we are still looking into it. But we just don't know if it works yet. And we do know that there are significant risks like cardiotoxicity, arrhythmia. So, you know, anyone who says definitely yes or no is not really speaking off the scientific evidence. And that being said, hydrochloroquine is a treatment for some immune-mediated conditions like lupus. So shortages of hydrochloroquine, like we are starting to see now because people are, you know, hoarding and acquiring the medication when it might not even work, could lead to, you know, dramatic exacerbation of these people's illnesses, potentially leading in death. There's no data to support that there's a prophylactic sort of use, so protection in the future. Okay. Everything that we're looking at right now is looking at treatment in people who already have the disease.
What about Nsaids? I guess like your ibuprofens and your kind of pain relieving kind of things. I put out before we did this podcast, I just kind of put out some questions to people, like if anyone had questions to ask, and a nurse friend of mine, she was like, what about that kind of stuff? Does that help?
So all of the data that I've seen right now says that there's, you know, again, no conclusive evidence, but we have a lot of sort of anecdotal, you know, accounts from doctors abroad saying that, you know, if you use ibuprofen, you might see an exacerbation of the disease. It might get worse. It might slow down the, you know, getting better. It might slow down recovery. And, you know, we're sort of, you know,
Uh-oh, it looks like you froze on my end. All right, we got cut off, but you're back. And we were talking about the Nsaids, and it sounds to me like you heard that they actually prolong the disease itself.
Mm-hmm. So there's, you know, the jury's still out scientifically. There's not conclusive scientific evidence to say that it's definitely bad, but we have heard a lot of anecdotal data from, you know, doctors abroad saying that you shouldn't use ibuprofen specifically, but acetaminophen is fine. You know, I was talking about this with some of the people in my lab, and we were sort of like, well, you know, is it scientific? No, but, you know, if doctors, you know, on the front lines are saying don't use ibuprofen, you know, use acetaminophen instead. If acetaminophen works just as well, then so I'll listen to them. What do you got to lose?
Gotcha. Can we talk maybe a little bit about how does this disease actually infect people? Like, how does it work? Like, what does it actually do to somebody?
Okay, so basically, you have these receptors called ACE2 receptors. You might have heard mention of them in the news or something, but they are in your respiratory system, they are in your kidneys, they're in specific tissues in your body, basically. And the SARS virus essentially has, with its little like spiked proteins on the outside, connects its protein to that ACE2 receptor. And, you know, there's a whole process, but essentially what this leads to is the internalization of the virus into the cell. And then the virus releases its genetic material, its RNA, and that gets transcribed into and translated into proteins. Actually, it's not transcribed because it's RNA, but it gets made into proteins. The host cell machinery just makes all of this, you know, stuff that then gets packaged into more virus, and then, you know, kind of comes out of the cell, and the cell dies. But what really is the problem with this virus is actually our immune response to it. that severe acute respiratory distress syndrome. And that's likely mediated by actually inflammation reactions from the infection in our lungs. And that is what causes, the shortness of breath, the scarring, the extensive damage. Our immune system works very, very well, but it is incredibly powerful, and it does, harm our own cells when it gets to when it gets sort of out of control. And that is, that severe disease that we see with SARS-CoV-2.
And then what I've been hearing is that people get pneumonia, and it's actually the pneumonia that they die from. Is that correct? Or some people do, not everyone.
Oh yeah, certainly like secondary pneumonia, or that is what you would call it. I think secondary bacterial infection. So basically, you clear, SARS-CoV-2 from your system, but in doing so, you're sort of at this point in time where your immune system response is sort of depleted, and that makes it, and that plus the damage caused to your lung tissue allows bacteria to start growing in there and cause pneumonia, and that can be a reason why people die related to COVID-19, even if it's not directly caused by COVID-19. And you see this also with like the flu, with pneumonia caused by the flu. Oftentimes it's not the flu itself that it causes the pneumonia, it's the secondary bacterial infection.
And why is it that some people are more affected? Like, I've heard that some people don't even get symptoms, and some people it's very severe. Like, what's the difference between the people that have mild symptoms or no symptoms, and the ones that have very severe symptoms?
Yeah, okay, that is a very good question. Let's step back a little bit and talk more about the idea of an asymptomatic person. So when we think asymptomatic, we're thinking no symptoms ever. You just feel fine. But in practice, when we look at people who are labeled as asymptomatic, it's because they don't have symptoms at the time of testing, even though they tested positive, or they don't report those symptoms. So when we follow those people over time, we find that they maybe aren't asymptomatic, but they are pre-symptomatic. So they don't see any disease manifestation at the time of testing, but later on they develop symptoms. And you also have a problem with recall. So maybe they have symptoms, but they didn't think it was a problem. So, for example, I don't know, I've been, my throat's a little dry, but also I've been working from home the past few days. So I've been, drinking beer throughout the day. I'm a little bit dehydrated. That's probably it. I don't have a cough. I just have sniffles when I'm outside. It's probably allergies. Or I have a stomach ache, but, it's probably just because I ate something weird. And so a lot of the times when you follow up, you find that people have either developed symptoms later or did have symptoms, didn't think it was a big deal. But when we talk about true asymptomatic people, there's a lot of things that you can talk about there, a lot of factors that might play into that.
That's really interesting, because I think about that. When I was in college, I used to drink like crazy, and I smoked, and all winter I was sick, and that was just normal for me, right? So I'm wondering how many people that might be in that situation that it's normal for. Now I drink a beer and I realize that I have trouble sleeping at night. I'm I can tell the difference. I'm more attuned to my body, and I'm just older too, I think. And so that's interesting. So that could be a difference, that some people just, maybe a lot of times they're sick, or they get sick frequently, so they don't really notice that it's really a big difference, kind of a thing. So
I've heard a lot of reports of people testing positive for COVID-19 and being like, I thought this was just allergies. Wow. I didn't think this was a problem.
Sure.
And maybe it is, maybe it isn't. there's a lot of diverse symptoms for COVID-19. Some people are reporting, diarrhea, stomach aches, and those things, people might not think about when they're asked to report their symptoms. If they test positive, they're like, well, that's not a symptom. That was just me eating something weird last night.
Sure. And then why is this one more contagious than other diseases that we've seen?
So, this is a really salient question right now, and I think that we need to lay some groundwork. So let's talk about the R0, the R0, as you've probably seen it, in the news. It's pronounced R0. This is an important measure in epidemiology. It's called the basic reproductive rate. So in essence, the number of people that one infectious person will, on average, infect in a naive population. So this is estimated by, complex mathematical models done on current data. The nature of the model itself does affect the R0 value. So one, that might be why you see such different, R0s, anywhere from like 2 to 4. And it's used to... And
that's 2 to 4 is the number of people that someone will infect. Is that what you're saying?
On average, yes.
Yeah, okay.
And it's used, so the R0 is used to describe contagiousness. And it's very easy to misinterpret because it's not entirely static in practice. Because, people don't exist in a vacuum. There's cultural things in place, there's personal things in place. And so in practice, the R0 is affected heavily by biological and social and environmental factors. So for example, how big in the population you're looking at is your personal space bubble? We in America love our personal space, but I know some European countries, don't really care that much. How much intermixing does the population do? How healthy is your population and how old? How many people smoke? How many people have diabetes or hypertension? So it's not a biological constant. It's highly situational. And when we talk about, COVID-19 being more infectious than the flu, for example, there's a lot of things in place for the flu that affect this, the flu's like transmissibility, the flu's contagiousness. So for example, people who are most often at risk for respiratory illness are the elderly, the immunocompromised, and young children, although for reasons we still don't really know, their young children aren't as affected by COVID-19. But for the flu, we have things in place to protect our most vulnerable population from the virus and the disease. So we have vaccines. Like PSA, always get your flu vaccine if you can, unless a doctor tells you not to, because the vaccine could either prevent you from getting it or it could shorten the duration and intensity of the sickness. And that is important because it means that there's less time that you're infectious. We also have prophylaxis for the flu. So your doctor might prescribe members of your household like Tamiflu, I think it is, if one member of your household is sick. And that's supposed to be protective so that people who aren't sick don't get sick. So even if you are around an infected person, we have protective measures in place. And the last sort of salient point is that the flu circulates every single year. So you're real likely to have some sort of prior exposure, and that sort of prior exposure to the influenza virus might be cross-protective depending on the strain. So it's thought that in 2009, the H1N1 pandemic wasn't as bad in the United States as it could have been for us, because it is theorized that maybe the United States population, experienced a flu strain that was similar enough that we had some sort of cross immunity to it. In 2009 to 2010, only 12,000 people died, and that's, you know, still a lot of people for H1N1. But, you know, when we talk about current statistics, I was looking it up before this conversation, and there are over 8,000 people currently dead from COVID-19 in the United States.
Jeez, wow.
And we just don't have that for SARS-CoV-2. We don't have that for COVID-19. We don't have treatments. We don't have the vaccine. Our entire population is, you know, sort of naive to this. There's not good evidence of cross-reactivity between this coronavirus and other coronaviruses that we've seen. So it's certainly a different, you know, landscape for this disease. And when we compare it to another coronavirus, another, you know, important coronavirus, SARS, the original, so I'm just going to call that SARS-1, even though it's just called SARS. You see infection more for SARS-2 than SARS-1. Paradoxically, because SARS-1 was a worse disease. It had a 10% mortality rate. I think some estimates were like 10 to 15. And it was just, you know, a horrible disease. But on the other side, it was very easy to find the cases and diagnose them and isolate them from the population. And also, you know, with SARS-1, you were not infectious in the 24 to 36 hours before, you know, your symptoms started. But in COVID-19, because the disease can present so mild, you know, you don't often see it, and it's not as easy to detect.
Yeah, and I also heard that it'll be like a 7-day incubation period where you might not show symptoms for 7 days. Is that correct?
Yeah.
And why is that?
So I think the infectious period is like 2 to 14 days, median of 5. But basically, it's interesting because infection is, you know, sort of a slower process. You know, biological processes are kind of slow. You know, again, like I said before, a lot of the symptoms you see are due to your immune response to the infection. So there's a number of steps you have to go through before you even get to that point. So you need to, you know, have the virus invade your cells. The virus needs to repurpose the cell machinery, replicate, and spread to other cells. And it needs to have a large enough effect that your immune system mounts a large enough response that you start on a whole, like, organism level, start seeing the effects. And I mean, there's 37, I think, trillion cells in our body. So it does take a while, often, for us to mount an immune response that, you know, we can physically tell.
36 trillion. Wow, I didn't know that. That's a lot.
Yeah, there's a lot of cells. Not all of them can be infected by SARS-2, but, you know, it's just giving you an idea of how large of a dissemination it would have to have before it starts, you know, making a dent. But
with SARS-1, you get it and then you pretty much see the effects immediately. You'd have that response a lot quicker. Is that right?
So SARS-1 was, you know, a much more virulent disease. It was a lower respiratory as opposed to an upper respiratory tract infection. So we see mostly upper respiratory tract infections with COVID-19. So like coughing, sneezing, it's you know, really concentrated up here. Okay. It can go to the lungs, but, you know, SARS-1, in my understanding, was almost exclusively the lungs. And there are, you know, some molecular reasons why this might be true. It might be because the binding domain of the spike protein in SARS-2 is a much better binder, and there's much less ACE2 receptors up here. So because it's so good at binding, it binds to these receptors up here and maybe doesn't, infect all the way down here. But SARS-1 wasn't as good at binding, so it didn't really affect, your upper respiratory tract. It really only affected where there was a lot of ACE2 receptors, in your lower respiratory tract.
Gotcha.
Lower respiratory tracts in general are more severe than upper respiratory tract infections. Not always, but mostly.
Gotcha. So your first talk that you gave at CypherCon, it was on bioweapons, right? Is that correct?
Yeah.
So is this a bioweapon? I think one of the things I've heard is, where this emerged in Wuhan, there is a bio research facility that's like 20 miles away from there. So some people are saying they could have just made it and then said that it was in this wet market. Could that be the case?
No.
No.
Short answer, no. There has been real interesting work on the genome of SARS-CoV-2 and looking at it and trying to see if there is any sort of, biological fingerprints, the clues that someone might have been messing around in there. There's not.
What would you look for?
So a lot of things that you would look for are, similar things to other viruses that you don't see in the native circulating coronaviruses. We did see that there was 96, I think, % genetic identity with another coronavirus isolated from pangolins, and also very high genetic similarity to a virus isolated from bats. We think that this coronavirus, this specific coronavirus, SARS-2, started in bats and then jumped to humans. And it's just, the thing with the biology research facility is that, yes, there is a BSL-4 lab in Wuhan. So
what's
that
BSL mean?
BSL means biosafety level. Okay. So it has an increasing, order of severity, which sort of means at BSL-1, these are things that don't cause disease in humans. BSL-2, maybe it causes disease or even severe disease in humans, but it's real hard to contract if you're working with it. BSL-3 are, diseases that can cause severe disease and can be transmitted through inhalation. BSL-4 is for research on things that, that can cause severe disease and don't really have a good treatment. But we have multiple BSL-4 laboratories in the United States. The existence of a BSL-4 laboratory doesn't prove anything. And from what we have, investigated on the virus itself, there's no evidence of it being a bioweapon. And also, it would be real bad practice for the Chinese government to just release a bioweapon on themselves.
Yeah.
I did see this Russian conspiracy theory early on that it was actually the United States that created this bioweapon and released it in China, but that would be kind of stupid considering how we responded to COVID-19 in the United States.
Well, my thought was, if it was China and they were doing this, yeah, it'd be a bad move to do it on their own people. China also plays the long game, though. They plan things out for a really long time. And so my thought was, if it was the case, they would, obviously they would have, and they have had, horrible repercussions on their population. However, they, being a communist government, they were able to contain it, I think, a lot better than the United States could. So, you know, if that was the case, you know, they could potentially know this ahead of time and realize that, you know, they would be better off to contain it than, you know, our country, for example. And that would be kind of a, I don't know, a strategic advantage, I guess, being a communist country.
You know, the strategic advantage kind of fades away when you really look at the immense economic impact
Sure.
that this pandemic has had globally,
Right.
and especially on China.
Right, exactly. Yeah,
like,
so they, yeah, because
all the
all their
travel
stuff's
was
made in
stopped.
China. Yeah,
Yeah.
right.
So, you know, I don't think anybody's really a winner in all this,
No, I
except
don't think so.
maybe the virus itself.
Yeah, well, and that could be the case too. You know, like a lot of people think that this is the Earth being like, "Hey, stop it! Like, chill out." And like, this is our, you know, Mother Nature's way of saying, "Hey, like, take a time out."
So, I will say that, like, as a scientist, I don't really subscribe to that sort of idea. That being said, we've seen, you know, several zoonotic jumps of coronaviruses from, you know, bats to humans, and this is likely not the last. I mean, 2 in 20 years is super common for you know, on a like zoonotic level, because that's an incredibly like difficult thing for a virus to do. You know, it's not necessarily that nature has a vendetta against us, but I think especially with our global society that we have now, and you know, the interconnectedness that we have, it's incredibly salient now to start building up, you know, global public health infrastructures so that, you know, these sorts of things can be responded to in a timely way.
Yeah, I wanted to ask you about that. Like, what do you think about the United States and the world's response to this pandemic? And what would you do if you were in charge? What would you do differently?
All right. So on sort of a global scale, we see very different responses. The United States didn't really acknowledge the problem until, you know, late February, early March. But I know that in my classes and in, you know, with the, you know, people who have been working in the field for a long time, I was hearing that SARS-2 was going to be the next pandemic in late January.
Wow.
We knew about this for a long time. And, you know, we should have been taking that time to ramp up our testing capacity, develop diagnostics, you know, start, you know, preparing for the worst here, you know, screening and isolating cases. I know that, you know, people coming back from China were told to quarantine, but not people coming back from Italy after, even after Italy started experiencing some really bad outbreaks. When you compare what's going on in the United States to what happened in, for example, South Korea, where they had widespread drive-through testing, they, you know, tested a huge population, they had great public health response. They didn't really do shelter in place or quarantine, you know, sort of practices that we see, and yet they really managed to, you know, mitigate a lot of the transmission that was going on. You know,
Just by testing early, like that was a big thing. It's
just by, you know, detecting these cases and you know, having proper isolation of those cases. Because if you look at the phylogenetic tree, so the genetic tree, like the family tree, if you will, of these of the viruses that we have sequenced in the United States, you will see that a good chunk of cases can be directly traced back to one case in late January in Seattle from one person who had returned from China.
Wow.
So if we had, for example, caught that case, or, had a little bit better surveillance, maybe we could have stopped that entire, branch of viruses, of coronavirus, SARS-CoV-2 infection here. And, there are other events where people brought COVID-19 over from other places as well, for sure. But, once it's in the population and circulating, it's incredibly hard to get a handle on it, especially if you're not testing. Because, people, like I said before, people who don't have symptoms or have mild symptoms, they were just going about their day. They didn't realize that anything was wrong.
Right. And at that point, you can't trace it back and figure out, okay, well, who are all these people that you interacted with, and like, who were they interacting with? And so who has it, who doesn't have it? And so, yeah, that's just the hard thing about this one, right? Because of the mild, severe symptoms, we don't know. And so like the only way to really fight it is to sit on the couch, right?
Yeah, so right now, for the average person, like, the best thing you can do is stay the fuck home. Like, don't go out, don't, run the risk that you might be infected and bring it home to your loved ones, and don't run the risk that you transmit this disease to someone who might be immunocompromised, or, might have any number of factors that lead to them having severe disease.
Yeah, I've seen this meme like on the internet, like your grandparents went to war, you're being called to sit on the couch, like you can do this.
Yeah, and of course it's important to remember that it's okay right now to be stressed out.
Yeah.
And it's okay to be a little bit scared. It's a scary time. Like, social distancing is incredibly stressful. Humans are social creatures, but this is important.
Yeah. So can you tell me a little bit about like the quarantine, like how? So I mean, the goal is to flatten the curve, right? So that we don't like overwhelm the hospital system and the healthcare system. So how does a quarantine affect the numbers?
Okay, so a quarantine would affect the numbers in that, each person, if they are actually being quarantined, they're less likely to come in contact with an infectious person. And if they are infectious, conversely, they are less likely to come into contact with a person that can be infected. So when you quarantine and you practice social distancing, you really lower that potential rate of infection. And when I was talking earlier about the R naught being a sort of plastic measurement, when you put quarantine measures in place, you're essentially lowering the real-time R naught, if you will. Like, because you're less likely to come into contact with people, you're less the number of people that you would infect goes down. So you really see, and when you factor in, sort of the exponential growth of a pandemic, if you get this, early, if you start social distancing, start quarantining early, you can prevent hundreds of cases down the line over multiple rounds of transmission.
Yeah, that's what I actually early on, like I think it was like the beginning of March, Getzman actually shared with me this video that showed like the exponential growth, and like as humans we don't really understand exponential. We don't think in exponential terms, we think in like linear terms. So like you know, a couple people are getting sick and people are like, what's the big deal, you know? But if you look at this exponential curve, and it's that rate of change from day to day. So like, I think at the time it was, and I don't know what it is now, and I don't know if you have these numbers, but like it was a 30% increase from the one day to the next. And if it stayed at that rate, it was like after, I can't remember the numbers. It was either 60 days or 100. I think it was 60 days. It was 100 million people that would be infected. But if they changed that rate down to like 5% per day, that 100 million number went down to, and I'm probably getting these numbers wrong, but it went down to like 400,000. So it's just a huge difference. And that's really what we're attempting to do with the quarantine, right?
Yeah, so we are trying to, you know, stop like, you know, those few infections that'll happen around us today, so that hundreds of infections don't happen tomorrow,
right?
Essentially. And, you know, it's so vital, because you talk about flattening the curve, but what does that really mean? I mean, so a few weeks ago, I was talking to a professor at Berkeley, a professor of infectious diseases, and he gave me the numbers. He said in the United States, there are 62,010 hospitals. In those hospitals, there are 909,200 staffed beds. 10% of those are ICU beds. So the bed that you would want to be in if you are, you know, needing to be intubated. You're having very severe symptoms. You're having very severe disease. That, of course, that number is likely changed by now, because, you know, hospitals are repurposing conferences and lobbies to act as makeshift wards, or repurposing like sports stadiums to act as like emergency hospitals. But, you know, those were the numbers a few weeks ago. And, you know, if you even if you were able to staff all of those available ICU beds, if you saw more than 90,000 or so cases of severe diseases that needed that, you know, that equipment and that treatment, then you'd have to make a very, very tough ethical decision of who gets the treatment that might save their life and who doesn't. And, you know, for each person, that treatment may or may not save their lives, but if they don't get that treatment, they are likely to die. And so that is the sort of thing that we're trying to steer away from. That is the worst case scenario, because then you'll see what we see right now in Italy, with, you know, incredibly high death rates, because their healthcare system is just overwhelmed.
How do you think the healthcare system is going to change as a result of this?
So I can only hope, but I hope that there is a push to invest in public health. You know, public health is one of those things where it's invisible if it's doing its job. You can't, this is not, especially in, you know, times when there's not a pandemic going on, these things are important, because having that, you know, global surveillance, looking at, you know, the potential things that might spill over into humans, creating infrastructure for widespread testing. These are things that can only happen over time. I mean, it's sort of like brushing your teeth, right? You know, you can sort of meander along until you start having a toothache, and then after you start having that toothache, you can brush 5 times a day, and it won't really, you know, do all that much. You need to go to a dentist. You need to get it taken out. You need to get it. You need to get it, you know, addressed. And so right now, a lot of the problem with our public health system in the United States is that we're just so understaffed. There is not enough people working in the CDC to do the things that we need to. We don't have the testing capacity that we, you know, should have in this scenario. We can't test, broadly the population. We have to save our tests for people who have severe disease or who like present with, symptoms in a hospital. And this is a problem because now we don't know how widespread it is in the population. We don't know if, a few months from now, if we see the case number go down and if we still haven't tested by then and we don't know the prevalence in the community, how do we know that if we let up our quarantine that we won't just get sustained transmission again? These are things that would be helpful to do as early as possible.
Yeah, you can't, I guess once you start losing your teeth, you can't brush them and then hopefully they grow back, right?
Mm-hmm.
It's like, you got to do the prevention stuff beforehand. And so, yeah, hopefully we learn this as a lesson and start putting in some of that infrastructure in place so that we're able to contain these things in the future. Any predictions at, when we might sort of get back to normal?
So this is probably going to be disappointing, but it's just, I'm going to say what all the other public health professionals are saying. It's too early to tell. I do know that, I was talking with a professor of mine who worked in the CDC for decades, and he was saying that he would be surprised if all of this was all over by like August. Now, what exactly that means is, another question. Like, does that mean that some people can go back to work? Does that mean that, you'd be surprised if like all of it was over, so we don't have COVID-19 anymore, or what? I don't know, but there's a lot of important questions there. For example, is it seasonal? Is it going to start to ramp down a little bit as the weather gets warmer? We don't know that yet. And even if it does, will it, like other seasonal diseases like the flu, for example, just come back once it gets cold in the winter again? I think that if it is seasonal, then it is likely to come back. But I could be wrong. There are several things that we don't know.
Yeah. Well, this has been kind of doom and gloom. I'm going to try to maybe try to end this on a little bit of a positive note. I know for me personally, like, it's just been so weird, and like I've had like this weird anxiety that I've been like, it's just so bizarre, because like I want to go out and help, but like people are telling me the best thing you can do is stay inside. So that's what I've been doing. But I've been getting out on my bike every day. I've been going for a bike ride so I stay sane. So I just want to give some suggestions to folks. If you're feeling antsy, like you can go outside, go for a walk, go like get some exercise. Make sure that if you have a meditation practice, or maybe you don't, and for me meditation really is grounding, and it's been very helpful for my life. So I want to recommend to folks to find some quiet time to pause and reflect, because this is a good time to do it, because a lot of the things that we've been normally been able to do and go out and do, and we're not able to. So those are a couple pieces of advice I have. And do you have anything that you'd like to share with people?
Yeah, I mean, it's important to remember that you are not alone in all of this, and everybody is feeling these feelings. I've been Skype calling, video chatting with friends. I've been playing video games online with friends. I've been, reconnecting with people. My lab does a weekly journal club where we read recent articles about COVID-19, and we also have a drink, talk about them. It's important to reach out right now.
Yeah, for sure.
And it's, a struggle for everybody. And, we don't talk enough about how much of a struggle it is for, the essential workers out there, not just the healthcare workers, although certainly the healthcare workers are weathering a lot of it themselves, but, the grocery store employees, the people making your food that you order on Grubhub or whatever.
The truck drivers that are delivering the food.
Postal workers.
Right, yeah.
It is a stressful and, very scary time right now, and it's important that you reach out, and it's important that you connect with other people in ways that you can, in ways that are safe for you. Definitely get outside and take a walk, stay 6 feet apart from people, but do that. It's stressful, but this is doing a lot. People out there who are, stressed out and in their homes and feel trapped, you are making a difference.
That's a good thing to remember. Yeah. So I think that's what we can take away is stay the fuck home, and you are making a difference.
Yeah.
Have your digital happy hours. You can get creative with, things, ways to stay in touch with people. At least we live in an age right now where, we do have the digital technology that is allowing us to connect with people.
Yeah.
We do have that. So it's not the same by any means, but it's, it's better than not being able to connect with people. So
yeah, it is certainly better than it could be.
All right, Michelle. Well, thank you so much for taking the time to kind of walk us through the whole COVID-19 and learn about everything that you're doing and enlightening us with your wisdom and intelligence. So much appreciated.
Thank you for having me. It's always a pleasure.
All right. Well, hopefully we'll see you next year at CypherCon.
Yeah.
We'll see what happens.
If CypherCon's going on next year, I will be there.
All right. Well, thanks a lot, Michelle.
Okay.